Number 23, Lewis electron dot diagrams for the carbon dioxide and sulfur dioxide are given above. The molecular geometry and the polarity of the two substances are, well, it says same, different. It's definitely freaking different. It's so different because if you think about it, carbon dioxide, as we should all know, this thing is a non-polar compound, right? How is this non-polar? Because if you look at the dipoles, well, oxygen is more electronegative than the carbon, so it's going to go this way and it's going to go this way. And as you can see, they are going at a 180 degrees on the opposite direction, so they're going to completely cancel each other out. So that's how it becomes non-polar. Whereas this sulfur dioxide, they drew it like it's linear, but it really isn't, and everybody should know that, right? We have a lone pair, a single bond, and a double bond. So technically this thing is, well, supposed to be trigonal planar, but is it really? Absolutely not, because this thing is not a bond, right? So what is it going to be? This is more of a bent shape, right? So the molecular geometry is definitely way different. And in terms of also the polarity, absolutely different too. Because if you compare between sulfur and oxygen, well, oxygen is above sulfur. It's a smaller atomic radius, aka it's got better ZEF, effective nuclear charge. So the way it's going to pull the electrons is going to be better, aka long story short, better electronegativity, higher electronegativity. So the dipole is actually going to flow away from sulfur towards the oxygen like this. So the polarity is absolutely different. This thing is very polar compound. So let's take a look at what it says. Well, first of all, just go ahead and get rid of A and B because they're ridiculous. It's not the same. Now, let's look at the explanation. C, different because the lone pairs of the electrons on the sulfur atom make it the negative end of the dipole? Absolutely not. Look at this diagram once again. The negative ends are heading towards the oxygen. Oxygen is more electronegative than sulfur, so it actually drags the shared electrons away from the sulfur towards the oxygen. So dipole is actually not sitting at the sulfur end. The dipole should be sitting at the oxygen ends. So that's absolutely false. And D, different because sulfur has a greater number of electron domains. What that means, the regions of electron density, like so it's got more heavy density of electrons surrounding it than the carbon does. And absolutely, right? Because if you think about it, sulfur is a bigger atom than carbon, so it's got better polarizability, so it does have that bigger electron density. So now, even if you guys didn't really understand what choice D really had to say, you can kind of just guess because once again, they should definitely be of different polarity and different molecular geometry, so that easily eliminates the choices A and B, and whatever C says is absolutely false because like I said, everybody should know, like this is a pretty easy logic for anyone taking AP Chem, that oxygen is more electronegative than sulfur. So the dipole has to be sitting at the oxygen atoms, not the sulfur atoms. So when they say negative end of the dipole on the sulfur, that's absolutely false. So get rid of C, and even if you don't know exactly precisely what choice D is saying, you should still just circle it because that probably makes the most sense as compared to all three, which makes absolutely zero sense.